It's so I don't forget. As I
Yeah.
mentioned, my name's Cassie Sofing, and today on our agenda, we have just a little bit of mosquito data updates to share with you. I invited Holli Kohl from the Globe Observer program to talk about the new updates that have been released that I'm not sure everybody's aware of, but I was wildly excited about it, and I just wanted to pass that on to you all. I know, right? And then I invited also Marilé Colón Robles from NASA Langley, who works with the pacing guides because there's a mosquito pacing guide. And she has a whole host of them to share with you. And I just thought it would be a great idea to kind of, in a snapshot, hear from the people who have been instrumental in designing and making these changes and things happen firsthand. And then to wrap up our whole webinar today, I have Dr. Rusty Lowe talking about how to take really great pictures and why it's so important. To kind of give you an update on our mosquito observations, cumulative, we have made we as a community have made over 34 or 37,000 observations and eliminated 22,000 plus habitats. So that's a big woohoo for us since we've started collecting mosquito data. And if anybody would like to check out how I got this information, it's geospatial.strategies.org. And this is the map that came when I queried how we've been doing this year. So this year we have made over 1,700 mosquito observations, but most importantly, out of that are 598 larva photos. And Dr. Lowe will talk about why those larva photos are so important and how we can pick up our numbers and make even more contributions. Hot off the press, and we're so excited about this, but the mosquito data that you've all been making has contributed to our second publication in the journal Insects, and I'll let Dr. Lowe talk about that.
Okay, just a quick moment. The Globe Mission Mosquito team is collaborating on a National Science Foundation funded project to improve the ability of AI and machine learning tools to recognize mosquito larvae. And of course, I think if you were part of our campaign last year, you know we had this big request for lots and lots and lots of photos because when you develop AI data, when you're developing AI algorithms to actually recognize pictures, you need to have thousands and thousands of images in order to train and test those algorithms to show that they have fidelity. And so the work that you have done as part of our community has really improved those algorithms, and we're now just beginning to publish on this. And so just 2 weeks ago, this paper came out by Dr. Ryan Carney, who is the PI of the project. We also played a big role in writing and putting together this paper, and your data is recognized here. And so thank you so much for this. And you can see here that one of the things that we have done is we have been able to take our data, our globe data, we aligned it to Open Geospatial Consortium standards, as did the mosquito alert data, which comes from Spain, and iNaturalist, which is found all over North America and also in other parts of the world. So these are all the mosquito habitat and land cover observations that are listed in this database. So this allowed our data plus other data to be utilized in this big, big process. So very exciting stuff, and it's all because of you. Thank you.
Thank you, Rusty. I threw this in because Rusty has been so busy. I just thought everybody would like to know that she's starting the second half of her Fulbright funded research. She'll be leaving for Brazil August 21st and coming back on the 20th. But the cool thing is who she's working with, the Brazilian Space Agency, and she'll be doing some globe workshops and globe observer data collection while she's out there. She in the past has worked with the Zika bus, which is why that article is there. and she has some blogs that are published, and you can check them out on the Observer website. And there is an official press release about the work that she has done with the University of South Florida with the link that's there. And when we post our webinar, you'll be able to click on those links and check out more information there. So Rusty, we're proud of you and wish you the best and you as you head out again.
It's all about what we're doing as a team, Cassie. Thank you
Yep.
so much. Yeah.
Holly, I'd like to turn it over to you. And I did embed your slides if you wanted me to just keep going, or if you want to share, that's fine too.
No, that is perfect. Thank you
Okay,
so much.
sure.
So I did put my contact information on here. So if you have any questions, feel free to reach out to me. But you can also reach me through, the little question mark help button in the app or on the website, or through the Mission Mosquito team. They all know how to reach me. So if you have any questions, please feel free to reach out. Go ahead and go to the next. So there's been, I don't know, there's been so much going on lately that you may not have noticed, but there have been some big updates in the Globe Observer app and on the website, and I wanted to make sure to share them with you. The biggest one is that you now have the ability to have a screen name if you are a citizen scientist or a student in the Globe Observer app or in the Globe program altogether. And in the past, we have kept these two groups of people anonymous. And we did this deliberately because we want to be very careful with people's privacy, because both of these groups of people have the potential to be under the age of 18. And we do want to be careful to protect privacy when we don't know, who you are. And so we hadn't identified individuals in the past, but now you can be identified by a screen name. So when you log into the app, you will see that you have been assigned a screen name, that it's an anonymous series of letters and numbers, but you can change that to something that you want. So to do that, open the app and you click on that little gear icon down in the bottom, on the bottom right there. Thank you so much. I'm trying to do that with my mouse and it isn't working on the presentation screen. When you click on that, you'll get the settings page. And this is what it looks like. You'll see your account there instead of mine. And you'll get your user ID, and then underneath that you'll see screen name, and you'll see that anonymous series of letters and numbers there, or that not anonymous, that random series of letters and numbers there. And you can click that blue edit button. And when you click the blue edit button, you're going to get that next screen, and you get two drop down fields, and you can select from those two fields whatever combination of terms that you want to choose. So I am Mountain Wanderer, and the system will then append a number to that to make it unique to you. So I'm Mountain Wanderer 2. And then you update it, and that is your new screen name. So when you go through the system, you go through the data, and you see Mountain Wanderer 2, you know that's me. And you can identify yourself in the system that way as well. So students can do this, and citizen scientists can do this. Now, if you are already a Globe educator, your name is in the system. You already have a name in the system, and you're already identified by your own given name. You already have the ability to change your name to whatever you want. So if you want to choose one of these names, you can choose one of these names, but you're already identified as, Jane Smith or whatever your name happens to be. So you're already identified in the system. So this would not be something that you will see when you log in on your account. But if you're a citizen scientist, this is a new thing and you will see it. So next, you can also change your screen name on the website. I'm showing on the Observer website, but this is true on the Globe website as well. So when you log in, you see the little, when you get to the Globe Observer website, you see there's a little icon on the top that has a person, or it will say log in. So you click there, you log in, and then once you're logged in, you see the little person. You click on that little person up there on the top right, and you'll get an account settings. So I showed the little drop down thing there. So you click on that account settings thing, and this is the screen you get. The first menu option there on the left is your information. screen here. And that's where you're going to change your screen name. And again, it's the exact same process. You're going to have those 2 drop-down fields that you get to select from, and it's going to, you choose Mountain Wander or whatever combination of terms you want to choose, and it will add that number to it, and you get a unique screen name. So you can change it either place, wherever you're most comfortable. Okay, next page. So along with that, you'll see that there are some changes on your My Observations page. Now, to get to the My Observations page, you can do that in the app. You'll see there's a My Observations link in the app. Now, you see that a few places on the app, but you can also see it on the, actually, you could go back to the previous screen really quick. You see it on the website, and up on the website, when you're logged in, there's that little blue button on the very top next to the person that says View My Observations. That's the other place you can get to it. So you can get to the website, or you can get to it in the app. Okay, you can go ahead and go back to the next slide. Thank you. So when you go to the My Observations page, what you'll see now that's different is that you can sort your observations by date. Before, it just showed everything, and it might be kind of slow to load, but now you can sort it by date. So you just want to see what you did in the last month. Maybe you just want to see what you've done during the land cover challenge that's happening right now, and so you can restrict it to that time period. You can restrict it to protocols. So right now I have it restricted to land cover on my little example picture here. And so you can restrict it how you like, and you can also, what I'm showing is just my citizen science account, but if I were a Globe teacher or a Globe educator, I would have all the protocols. So whether I've entered that information through Observer or through a data entry system, I might have, say, my land cover and my water quality, and maybe I might have surface temperature. I might have all of the Globe protocols here to choose from. So everything that you've entered into the Globe system is available here in one place. So you can see everything that you have done within Globe in one place, which is new. And it's a really nice update. The other thing that I noticed that, I don't know, maybe it was here before, but I hadn't noticed it before, is you can see which teams you were on. So if you've joined a Globe team and you've forgotten which teams you've joined, that's me. You have a list of all the teams you've joined, which is really nice, because I joined a bunch and I forgot which ones I was on. So that's nice. Okay, so go ahead and go to the next one. All of this also is connected to the big update for the teams pages. So we have had for a long time the ability to create a team and to join a team so you can work together to collect data as a group. This is an old team that I created a while ago, a few years ago, for a Globe annual meeting in 2019. And there are 27 members of the team. What's different here is that, again, we can restrict. What happened before is when you showed the team page, you would get this map, and you'd still get the map, but it would only show, this was for Observer protocols, it would only show things entered through Globe Observer. So it would only show clouds, land cover, trees, and mosquito habitats. But now it shows everything that everybody's done, regardless of how they entered the data. It also gives you the ability to restrict the time period, which is wonderful, because if you want to, you have a team that you've had for a long time. Say I have everybody from this team that I formed in 2019, and now I want to bring this group together, and I want to create a competition with another team, and we want to see who can get the most data in the next 2 weeks. We have a way to compare that, just that 2-week period, which we didn't have that before. So you can restrict to that 2-week period, which is nice. Okay, go ahead and go to the next page. So what you're going to see if you scroll down the page is, before you would just see a list of, you'd see the list of Globe members. And so, you see the people who have joined. But now, because we have screen names, you also see the citizen scientists, who before you would have seen citizen scientists, and you'd have no idea who that person was. No way to identify that person, connect to that person, see what they've done or how they've participated. You'd see like their total number of data, but you wouldn't really see much else. Well, now you can see that I'm a member of this team. At least this particular version of my account is a member of this team. And here is another citizen scientist who has not updated their screen name. So here's an example of the random screen names. One thing I wanted to point out down here at the bottom is that this random screen names that start with GO indicate that that person is a citizen scientist, somebody who has joined the program through Globe Observer, and they participate through Globe Observer. If they are a Globe student, they will be listed as GS dash and then letters and numbers. So that's how you can tell the difference between the two. If they're a Globe educator or Globe trained person, then they will have their name here as before. So then you can click on that person. So if you want to go to the next screen, and this is as if I'm clicking on that Globe Observer or the GO-FC person, I can now get to their My Observation page. So now I can see what that person has done. I can restrict the dates again, because this is just their My Observation page, which is what I showed you before, and I can see everything that that person has done. I can see how active that person has been in the program. While we're here, this same structure is now available to teachers as well. So if you are a Globe teacher, you will get this structure for your students. So you will be able to create student accounts in batches very quickly, very easily, and you will be able to see your students in the same structure. You'll be able to see what they've done in this same structure and be able to click on their individual names. They will also be able to update their screen names. You can restrict the time period that they're able to update their screen names so they're not constantly changing. You can keep track of the students. And so if you're using this in a classroom setting or an informal education setting or whatever, it's a lot easier to keep track of your group, and you can manage and see what people are doing. So I think that will be a really positive thing in the education realm. So it's available both for teams and for educators, and they're parallel structures, which I think will make your life a lot easier. Go ahead and go to the next slide. So this is the update for Globe educators. So if you're not a citizen scientist, you're a Globe educator, you're trained in the system, and you have access to all of the Globe protocols. I referred to the teachers page a moment ago. The other thing that you get with this update is that all of the hydrology protocols are now inside the Globe Observer app, and as part of the data entry system. They're gradually moving over all the data entry into Observer so that everything is in one place for you. And so now hydrology is there as well. So as you're doing your mosquito habitat mapper protocol and you want to enter dissolved oxygen for that same site or pH for that same site, you can do it in one place. And I think that will also make things a lot simpler for you. So I don't know which one they're doing next, if it's biosphere or pedosphere, but those are coming. But right now we have atmosphere and hydrosphere in the system. Again, this is for Globe trained educators. This is not something available to citizen scientists at the moment. That is it for the updates. So feel free to reach out to me if you have questions.
So if they're not a Globe trained educator, the data entry would not even show up in their app. Is that correct?
That is right. If you're not a Globe trained educator, you don't even see that option in the app. So.
And you've gotten quite a few applauses as you were going through this part of this presentation. So it looks like that was a big hit, Holly.
Well, I will pass your congratulations on to the IT team who spent months and months working on this. This was a huge update they've worked on for a very long time, and it shows. They've really put a lot of work into this. So I'll let them know that you're very excited about it.
Thank you very much.
You're welcome. Thank you for letting me come.
Marilé, I'll turn the screen sharing over to you.
Thank you so much. Hello, everybody. I'm excited to be here. I'm going to be talking about the 1 week pacing guides. You might be asking, why is she here? I know. Well, we're all a big team. We all work together. I know that you know me more as the clouds lady, and please keep thinking of me like that, but I love all the different observations. And mosquitoes actually close to my heart because I'm from the Caribbean and there's a lot of mosquitoes down there. So um, I'm gonna give tribute to Miss Angie Rizzi, who made these slides, and she's one of the biggest workers on these pacing guides. She's part of our team, which is very exciting here at NASA Langley. She used to be a computer programmer, then became a teacher and taught for about 12 years middle school sciences, and that's how we learned about her because at NASA you can be a teacher intern and work with other educators during the summer. So it's a really exciting job to do. Um, a little bit about me. I am the project scientist for clouds. I'm from the Caribbean, so I have quite an unique experience being in the Caribbean in the tropics with mosquitoes and people getting sick around me and things like that. But I did fall in love with clouds. I flew in that big airplane inside and outside of clouds. I do love volleyball. I'm playing later today after this webinar, which is how I get to meet a lot of the people here on center. And I also love music. And I have 2 little ones who I'm teaching all about the environment. Yay! So some of you already know that we've hit 1 million satellite matches with cloud observations. Thank you to all who have made observations with the Globe Observer app. It's been amazing. We hit it not too long ago, and we want to continue it. So let's see how fast we can grow those satellite matches. So thank you so much. You can go to the Globe Observer app to learn more and celebrate with us still with the Globe 1M or 1 million satellite matches. And so today I'm going to go over what is the pacing guides, concentrate on the mosquito habitats. We are going to talk about the activities that are in it, as well as the resources and how to take it further. So in each pacing guide, there are multiple pacing guides, different topics, all related to observations that you can make. It starts with going outside and making observations. It has hands-on activities, and then it has a MyNASA data, which is a product. Oh, did it stop sharing? No, which is a product or a website for educators that shows NASA data in a way that easy for teachers and students to look at plots and make their own investigations. So with each pacing guide, there is a guiding question, a question that unites the whole week, long week. What is the biggest question or the anchor question? And for this, the mosquito pacing guide that we're focusing on is what conditions are favorable for mosquitoes. Okay, so you'll find this in every pacing guide again. For the mosquito pacing guide is what conditions are favorable for mosquitoes. You will see the phenomena. So we're focusing on mosquitoes' habitats for this one. Below that, you'll see the grade level suggested. Now, that doesn't mean that you as an educator cannot adjust it. You are the expert of your students, so you can adapt it, but this is our recommended grade level ranges. It also has a contact, and of course, you already here have Cassie Sophie, who is here connected, but you'll always have a contact for each of the pacing guides. Then there's a section about how to take it a next step. And so there's further investigations. If you're not a globe-trained educator, how can you become a globe-trained educator? And then access to all the pacing guides. So in that link, you can find all the different pacing guides and recorded webinars, similar to what I'm doing today, but just a little bit longer on each one, so you can dig deeper. We align them to the next generation science standards, and you'll see the performance expectations and the disciplinary core ideas. Again, these are suggested based on the educator team that worked on these pacing guides. In what we recommend is the grade level. There's also background information on why is it important, but also why NASA is involved or why NASA is interested in your observations. Of course, we have the great example that Dr. Lowe just shared of the newest research paper that was published. Here we simplify it a little bit. You can share with your students. You can use it as background information for yourself as well. And now, something that we want to point out is the importance of how NASA studies our Earth. And it uses different types of satellites. So here's geosynchronous meteorological satellites. The International Space Station is another type of satellite that has instruments as well. There are other satellite missions. There's CubeSats or small sats. Here at NASA Langley, we have a lot of aircraft data, and we fly the aircrafts. There's campaigns right now flying under the Calypso mission or the Calypso satellite track, which is one of the satellites you can match to when you make cloud observations. But most importantly, we want to point out that smartphones and citizen science data is one of those types of observations that NASA uses because it's so important. And what's happening is that satellites are looking from the top-down view. We are on the ground looking up in this particular place in the clouds. But when you're looking at mosquitoes, you're really looking at very detailed information that can be hard for certain instruments on satellites to detect, particularly larvae, right? Like that's like, woo, very difficult for instruments. But when you combine those 2 points of view from the satellites, maybe looking at precipitation or areas where land has changed, it might be more favorable for mosquito habitats. With your observations of mosquito habitats and presence of larvae, then that's when the powerful combination comes in and you have richer data sets. The mosquito, again, all the pacing guides are in the NASA Langley Globe partner page, and I'm going to put that link on the chat for you so you have access to this and all the other pacing guides. Again, there are also the recordings for the session, and then you can click and look in further detail the mosquito pacing guide. Now it's 5 days of activities. In day 1, we're suggesting to build the mosquito trap. And notice that for each day, we'll have a connection question or connection to that guiding question. Remember in the beginning, we had a guiding question, an overall question, anchor question. For day 1, this connection question that goes back to that overall reason why are we looking at mosquito habitats is which part of the trap is also found in natural mosquito habitats. So in this activity, you're making a trap, but is it what are similarities that you can find in nature or around you, and what are some differences as well. So we're hoping that with your students, you would notice that standing water and maybe some nutrients that you can add when you're building the experiment are part of that conversation. There's also different ways that you can, sorry, I'm distracted because I hear lightning and I'm a cloud person, so I get excited. There's a awesome video that you can see on how to build a really good trap. You can also do variations, either varying the color. If you notice here, there's a color of the paper. You can vary the location. You can vary the nutrients. So you can create this into either start with a simple activity and grow it into a research project. Then day 2, there's different activities that you can also do. There's the guiding question here is which mosquito habitats might be in your area, which we were kind of asking here in the beginning of the webinar, trying to figure out, are there mosquitoes? What is the seasonality? This is a neat activity where you can play it as bingo. It also, you can color your own, so you can, again, make it as interactive as you can. Day 3, then you go out and make your own observations with your students. So again, you have the background, you understand the why, you understand why NASA wants to study and is wanting your observations, then you can go and make your observations. And again, the connection to that guiding question when you're making those observations is were you able to eliminate any possible mosquito habitats? Because that is your contribution and the contribution from your students to make it better for the people around you, for your community. Now, day 4 here is where we introduce the My NASA data site. And I'm going to go to the site. And this is what's called a mini lesson. Remember, My NASA data has data from multiple different NASA satellites with activities and lesson plans to guide your students on how to read and access this data. What I want to point out in the mosquito habitats mini lesson is that here up in the instructions, this activity focuses on the Culex pipiens type of mosquito. And right here, it tells you that this type of mosquito needs temperatures at or above 12.5 degrees Celsius to emerge. When you keep scrolling down, it gives you instructions or the steps on what to do. And there's a graph that you can read. And then some questions, discussion questions. If we focus on the graph, we notice that the blue bars are the average precipitation. When we look at the x-axis, we have per month. This would be the average per month in the year 2020. In this y-axis, we have in degrees in Celsius. In the second y-axis, we have the average daily precipitation. The one on the left is for Memphis, Tennessee. This is a climograph. And then the one on the right is from Moline, Illinois. Both of these cities are in the same longitude. Moline is farther north, or at a different latitude than Memphis, Tennessee. I love this because I have family in Moline, Illinois, so I can completely relate to where they're at. And it's a very cold location next to the Mississippi River. Let's look at the questions now. And it asks, which month do you think the Colex ppns emerged in Tennessee, in Memphis, Tennessee in 2020? Remember now, what was the temperature that it needed to be? Minimum temperature that it needed to be? You can use the chat to tell me again. We discussed it up here. What is the temperature we need to look for? There you go. Thank you, Yvonne. 12.5, okay. 12.5 degrees Celsius. So let's go back to here. And I'm looking at degrees Celsius. 12.5 is right here. Okay. And we're looking at this black line right here. So 12.5 is observed in the month of March. So we can say that given that there's enough water or rain precipitation in this area and that water has accumulated, the temperature appropriate to see this type of mosquito would probably start in March based on the climograph for the year 2020. Okay, let's go back to the questions. Which month do you think the Colex ppns emerged in Moline, Illinois? Now I want you to type, let's look, I'm going to point it out. Here's 12.5 degrees Celsius. So in which month does this black line go above or equal to 12.5? Where is the first month? Yes, very good. So it's in the month of May. Okay, so again, My NASA data has all these activities where it shows you a data set if it's a mini lesson, and it guides you through questions on what to look through. The interesting thing is, so the next question is explain the differences, and we were talking about they're in the same longitude, but different latitudes, and you can notice that in the temperature, right? Moline is definitely colder than Memphis, Tennessee. And then what do you think if the temperature increases by 2 degrees? So this is an interesting one. If we look for, so the first month in Memphis where we could possibly see the emergence of this mosquito was March. If we go back to February, let's go back 1 month, and we increase the temperature by 2 degrees, it would still not be enough to have the mosquitoes in this case. If we go to now Moline, and we said that it was May, April, 10, it'll be 12 degrees Celsius. It's so close, okay? And so it might not affect it, but you might have more days by increasing the temperature by 2 degrees. So this is just a taste here of this activity with the My NASA data for day 4 of this 5-day pacing guide. And then for day 5, there's another mini lesson with a video and questions related to El Niño and the spread of human disease. And in this case, the connection to that guiding questions, how can changes in mosquito habitats affect human health? So the big question also is how and why does NASA study mosquitoes? And by being part of the mosquito habitat in these webinars, you're learning that. But in the pacing guide, there's also videos that can help you through, plus the background information. In the pacing guide, it was really hard to just pick one resource or just pick one activity per day. So at the bottom, there's additional resources, and they've been divided by online activities, hands-on activities, videos, and reading for you. Ease of implementation. We know that you educators are have a lot to do and are under a lot of pressure. So we've already planned these activities out for you by putting them per day and the sequence of activities. There's assessment options already built in. There's the questions that we just walked through. To build a story with collecting your own data or without collecting your own data. And then there's additional resources provided. The other pacing guides also have all these same parts. It's just the topics are different. And so we've been talking about mosquito habitats. We also have air quality or aerosols. We have cloud types. So if you just want to focus on the types of clouds, and it features the NASA Globe Cloud Gaze project, if that's available. There's also clouds and the energy budget. We know that especially middle school teachers have to teach about Earth's energy budget. So there's a pacing guide for that. There's also plant phenology, trees and the carbon cycle, and then urban heat island. So I'm going to stop there, and I appreciate being here with all of you. Thank you so much, and I hope that you all check out the pacing guides, and again, reach out to us with any questions.
Thank you, Marilé. That was awesome. And I hope that everybody has a chance to take a look at those pacing guides, because if you're just looking for a gateway to get into any of them, this is like next up to wrap up our webinar today, our pro tips. And I have Dr. Rusty Lowe on deck to talk about that. Rusty, I'll pull up your slides.
Hey, thanks, Cassie. I'm just so excited for these pacing guides because I think they are a wonderful way to get classrooms engaged in doing science, even in those upper elementary and middle school grades, and it's all made just so easy for you. So thanks again, Marilé, for the work of your team to create those guides. So I just wanted to finish up the last 15 minutes of our webinar today by giving you some pro tips about Mosquito Habitat Mapper. And I'm going to start by just asking Cassie to go to the next slide. And here's my thank you to all you citizen scientists that allowed us to contribute to that paper that was just published. We can't do it without you. So thanks again. Next one. So I'm just going to talk about these 6 points. We're going to look at some data. We're going to see the publications, and then I'm going to help you build your skills by giving you a few pro tips. So let's go. So this is just, I think this is redundant from what Cassie was talking about, but just look at what we have accomplished. There's more than 24,000 points there of places where you as citizen scientists have helped us collect data. There are areas where we've got lots. There's areas where we need more. So please continue your efforts. It's fantastic. Next one. So you are contributing to research. Next one. And we just talked about that one paper that came out recently. Here are 2 other papers. One came out last year, one came out this spring. And notice that in these papers, we always mention how important your contributions are. And you have access. You can have these are. We also have a commitment to publishing our data in open access journals instead of having things behind a paywall. And so these are open access journals. You can use these URLs, and you can actually go in and get copies of these papers for yourself. Okay, next one, please. So you all know why mosquitoes are so important because of disease. You also are probably aware, if you've been to more than one of these webinars, that mosquitoes are moving around because of climate. And they are moving their mosquito seasons that we just talked about, the data that Marilé was presenting. Mosquito seasons are starting earlier and ending later because our springs are coming earlier and our falls are ending later. And we do see this in the data. And we also have mosquitoes are hitchhiking to new regions on boats and plants and tires and all kinds of things. And in the past, they would hitchhike someplace, and they would not be viable. And so they would not be able to establish colonies. But what is happening is that nowadays, particularly with just 1 degree Celsius change that we have seen so far, it's opening up areas for colonization by these mosquitoes. And this is a particular problem, particularly when they are the bad guys, the guys that are vectors of disease. Next one, please. Okay, so you're improving global health by doing this work, and I want to go to the next one. And here I'm going to show you that this is an example of one mosquito that this is what we talked about in that paper, that if you use the mosquito habitat mapper and you actually get a larva and you want to report it, we ask you to take a picture, and then you take that picture, and then the picture shows up in the app, and then you look at different features. So here we're looking at the tail end of the mosquito, and we're able to see, if you look at these 4 pictures that we have of mosquito larvae here, you can see none of them have those elongated siphons. And the Anopheles mosquito, which is the mosquito that is the genus that carries the malaria microorganism, the parasite, those are found in this Anopheles. And so this is an Anopheles mosquito. Well, there is a new Anopheles mosquito that was never found in Africa until 2012. And only recently, and I'm saying by only recently, I mean really in the last 3 or 4 years, are we beginning to see the establishment of colonies of this dangerous invasive mosquito. So this is the research that we are doing in conjunction with the President's Malaria Initiative, PMI, and we are doing this research as part of a NASA-funded project of which Globe Mission Mosquito is part. Next one. So this is our team. I showed this last week at the Globe meeting. So if you were at the Globe meeting, you might have seen all these people, but we have a team including people from Ethiopia as well as scientists from different universities. And we are all working together on this project where we are trying to identify this particular malaria causing mosquito, the Anopheles stephensi, and we are developing AI so we can recognize that mosquito from the photographs that you are providing. So I'm trying to tell you why your photographs are so important, okay? Because you are supporting this research. Next one. So, and I have shown this also, I think, even in this group before, because it's so exciting, but you just never know when the data you collect will be important. And in this case, back in 2020, a citizen scientist in Madagascar recorded a mosquito in a tire, so you say what the habitat is, you upload a picture of the habitat, and then we ask you to look and see if there's larvae. And if there's larvae, we ask you to upload a picture of the larvae. Well, the interesting thing and the particularly dangerous thing about Anopheles stephensi, this bad actor vector species coming to Africa, is that it's not like the other Anopheles mosquitoes, which usually you find in rural areas. They're found in irrigation ditches. They're found in natural water sources and wetlands, but they are not found in flower pots or containers. Well, this mosquito, Anopheles stephensi, is different. It is a mosquito that preferentially raises its young, it breeds in containers. So when we saw an Anopheles mosquito in a tire, we said, oh, this must be a mistake. What is this? So we went and looked at the data, we pulled up the photos, and sure enough, that is clearly an Anopheles mosquito. It does not have the siphon on the end that we recognize as being any one of the other 40 genera of mosquitoes, right? Anopheles is the only one that doesn't have an external obvious siphon. And the second thing is, yes, it was not a natural source. It was in a tire. Well, this particular mosquito was used by our project in the development of this AI, and it looks like our AI is able to recognize this Anopheles mosquito, and we are working towards, I think right now we've got like 70% accuracy maybe, but we're working towards being able to have very accurate assessments of the mosquito and validating it in terms of genera, and species. Next one, please. So this is the context for why this is important. NASA Goddard Space Flight Center is an AI center of excellence. They are supporting a lot of different grants that are looking at developing AI for identifying land cover, for identifying mosquito habitats, and then the National Science Foundation project we're working on is looking at larvae. So this is really going to make all citizen science data in the future much more useful and important for scientists. Next one. So what I'm going to give you now the pro tips that's going to help us, because when I sat this summer and looked at all those, those 34,000 photos, I only looked at the ones in Africa this summer, but it was a big job, right? Okay, next one. I'm going to give you some tips about what's really important. And the first tip is not about photographing. It's about improving accuracy of your reported data. And I think this is really, really interesting, because if you've ever used the Mosquito Habitat Mapper app or the Land Cover app or the not the Cloud app, but the Tree app, you will see that when you open up the app and it says date, time, latitude, and longitude, it usually says 65 meters or 64 meters when it starts out. Well, that is actually not even really that's really not even it's not really data. What it is it just defaults to that until the receiver that you're using has a fix on the satellites. So when you look at this data, we see that we have what we call like a data anomaly, right? We have a lot of data at 64 meters. And can anybody figure out and mention, you could put it in the chat, do you know why we might have so many measurements coming in at 64 meters? I would love to hear your answers. So please go ahead and put something in the chat. But if you were using if you're using a phone as your GPS receiver, you're using a GPS service there. If you have, these phones can provide accuracy up to 3 meters. I live in a canyon in the mountains, so I can never get more than 12-meter accuracy. If you're living in a city where you have lots of tall buildings, it might be even a little bit less. But yeah, we can, you can get pretty good accuracy with these data. And yeah, and Michael, you are exactly correct, Dr. Jebbo. What's happening here is people are opening up the device and they click next and they start their observation without waiting to get a good fix. So it's really important when you open up your app that you press, there's a little reset button. I wish I put that on the slide, but there's a little reset button you need to press it a few times until the data the accuracy, reported accuracy does not get better. So this is really very, very, very important. And yeah, you don't need Wi-Fi though for getting the GPS. So it's not necessarily Wi-Fi necessary. However, Wi-Fi towers can improve the accuracy down to 3 meters. So thank you, Lisa, for that comment. Okay, so please, please, please take a few minutes when you open up your app before you start your observations. Keep hitting that reset button until you get until it stops becoming more accurate. And for most people, that's going to be around 16 or 12 or less. Okay, thank you so much. And the next reporting tip is related to what I just talked about earlier. And that is, next slide, that is the pro tip about observations. And, a little bit later on this fall, we're going to repeat by popular demand identification of mosquito larvae. But, and I'll show you exactly how to do this. But what you need to remember is that in the algorithm, in development of the algorithm for developing the AI, they are using data from different sections of the mosquito. The head, they're looking at the thorax, they're looking at the abdomen, and they are looking at the tail end of the mosquito. And also, not just the body, but also the hairs. So when you're taking pictures and submitting it to Globe Data, please take lots of photos. We recognized the importance of these photos when we developed the app back in 2017 when it first came out, and you can submit up to 9 photos for each specimen. And so ideally you would do one of the whole mosquito, so sort of the gestalt of it. And then we ask you to do terminal abdominal segment. So doing that back end of the mosquito that shows the tail hairs, and it also shows the siphon. Get a good close-up of that. But for the research we're doing, we also need heads, and we also need the thorax, and we also need the midsection. So go ahead and with the, if it's particularly if you're able to use the clip-on magnifier, or if you're actually using a binocular scope, which is even better, please try and get as many photos as you can. And it also helps if you take a toothpick, or if you take a little paintbrush, like a water painting brush. You can move the mosquito around a little bit, roll it over, and make sure that all the features are being displayed. And so don't hesitate to take up to 9 photos, because each one of those photos I promise, each one of them will be used in the AI development. So it's really, really important. So that is the big tip for today. I got 2 more tips and requests, and we're going to do those now, Cassie. The next tip is that, and this relates to what Marilé was talking about sensors from space. We have sensors on the ground, and the best way for us to connect our microhabitat mosquito data is to do a land cover measurement. So you kind of have like these nested observations. You got the mini habitat, the microclimate that you find in the mosquito habitat that you find. And then you embed that in pictures of the land cover. And then the land cover then is examined in conjunction with satellite data. And so this is the way that we can connect satellites in space to little tiny larvae on the ground that you can't see from satellites. So you are that connection. So please, one of the things we did when we built this app, which I think was actually quite smart, is that whether or not you want to use the land cover app, or you want to use the cloud app, or the mosquito app, or the trees app, they all are built the same way, basically the same steps. The only thing is the data you're collecting is different. So there is almost no learning curve when you change from one app to another. So for instance, I'd like to encourage all of you mosquito habitat mappers out there to contribute right now to the land cover campaign, which we're having this right now for 50 years of Landsat. I'd love you to also collect some cloud data, because we're trying to get all those cloud data for the matches, right? So anyway, this is the pro tip. Whenever you take a mosquito habitat observation, please also take the less than 2 minutes it requires to take those photos up, down, north, south, east, and west. And the nice thing is, if you've already waited for your satellite fix, it's already going to be at the high accuracy that you've already used if you've already used the app. So that's really cool too. So really, you're adding 2 minutes to your work. So thank you again for considering this. Mosquito researchers that are doing modeling are going to thank you. All right, and then I have one last tip, and that is, when do you want to take your observations? If you are living in a temperate climate like I am, we don't have mosquitoes all year. There is really no necessity to take pictures and say here's a habitat, but there's no mosquitoes. That data is it's good for training, but it's not going to be very useful for scientists. But once mosquito season starts, it's great to have those pictures coming in, and it's great to have observations maybe at the very beginning of the mosquito season, so we can see the first occurrence. It's great to see those last occurrences. We know from the work that we have done in laboratories, we were talking a little bit about in the chat and with Marilé, the times at which mosquitoes are usually found. What is very interesting is that lab observations and field observations are not always the same. And so we really do need to find this data. It's 21 degrees in Medina, Illinois, right? Medina, Illinois. Do we see mosquitoes? What we do, we shouldn't. Our lab data says we don't. Well, this is why this is really important. And mosquitoes are seasonal, and they're highly responsive to environmental conditions. So if you have a rain, you can expect to have, for instance, 10 days later, 7 to 10 days later, perhaps more mosquitoes. There's always a little bit of a lag time. If you're going through a drought, as it gets more droughty, you may start having mosquitoes as our flowing rivers puddle up and become stagnant in the riverbeds. So the bottom line is to contribute when it most makes sense in your location. And this is a really cool graph just to show you that we are all kind of taking turns around the world when we're collecting data. So for instance, the blue is, you can see that during the mosquito season in a lot of continental North America, it starts in April, it ends in usually around September. And that's every year, that's where we get the most observations from North America. You know, in Africa, you can see Africa had a lot of observations when they had a special intensive observation period associated with the Zika project. And we can see the most of the green is from Thailand. They have a very active mosquito program there, and they have year-round mosquitoes. So you don't really see the seasonality, but it's just very interesting to see how our data is geographically being reported over time. Next one, please. So that's really all I have to say today. But we are now making ways that we want to get you more involved in some of the data analysis, the data that we're publishing. So keep coming to our mosquito habitat mapper globe mission mosquito events over the course of the fall and the spring. And we'd like to get you more involved. We're going to talk a little bit more about AI. We're going to talk a little bit about preparing our data for analysis. And the last slide I have, okay, go ahead, is here we have, I just wanted to show you these beautiful pictures that were taken by a high school student. And in her trap, she put out a trap as part of an experiment she had, and she found a dead mosquito floating in the water. She found some, this is actually a larva, not a pupa, but she found a larva, and she found an egg raft of a Culex egg raft. So we get these really fantastic high quality photos, and they are just really great. And Cassie, I'm going to stop right there because we're already a little bit over time.
All right, well, I'm just going to skip through the slides then on my way to the last slide, see if there's
Okay,
more.
great. Thank you.
Thank you very much. I thought the pro tips were excellent. Just a good reminder of when we should be taking observations, and that's when it's good for you and your area. Our next webinar is September 8th, and we are going to be offering the first of its kind, the Mission Mosquito Larva Hunters Field Guide Training. Come for this hour-long tour, and I want to say it's going to be a deep dive into certain parts of it, but it's possible that you might leave with a larva hunter training badge. So please come, and we hope to see you on September 8th. Thank you so much for joining us today.
Thank you.